So we're going to talk about this dry farming project and some of the research results that we have found. So a little bit about the project. It's being funded by the Department of Water Resources. It's a 3-year project and it's just coming to an end. The objectives were to build a dry farming network, provide dry farmed vineyard consultations throughout California, research studies, create educational resources. We've hosted many workshops, webinars. We spoke at conferences. We are creating all these amazing educational videos, and I'll put the link to the websites in the chat. And we created a dry farming best practice guide, which will be available soon. A dry farming map, so a suitability map where you can look at the entire state of California, see every vineyard that is dry farm that we know of, click on it and get information about the spacing and the rootstock and all of this great information to help you make a plan if you want to start dry farming. And we're communicating the promote and promoting the adoption of dry farming practices to lessen water usage. So the whole idea with this project wasn't to get everybody to jump on board with dry farming, but to hopefully teach people some techniques to be able to lessen the water that they use in their vineyard. So, a quick definition of dry farming. So, dry farming is a farming technique that relies solely on utilizing the water naturally present in the soil, captured by the rain to meet the needs of an established vine without irrigation. In a Mediterranean climate with dry summers, this requires capturing winter and spring rain. The long-standing practice encourages deep root growth, resulting in high quality grapes that reflect the terroir of the vineyard. And so we're going to hear from 3 of our researchers today. So Miguel Garcia with Napa RCD is going to talk about his research in soil health and water storage in dry farm vineyards. Yvonne Sokolar with UC Berkeley is going to talk about the trade-offs and benefits of dry farming as a climate resilient strategy. And then Mike McCullough with ERA Economics is going to talk about the costs of dry farm vineyards. And please, during the presentations, put your questions in the chat and we will ask, I'll be sure to get to them at the end. So Miguel, do you want to share? You're on mute.
Yeah, it wants to share my entire screen for some reason. Give me one
Okay.
second here. Okay, much better. All right, hello everybody. Miguel Garcia with the Napa Resource Conservation District. My portion of the study deals with looking at soil health indicators and how is water stored and mobilized in dry farm systems. There is just not a lot of information available related to how soil health is happening in dry farm systems and how the soil is performing. So as one of the primary objectives for my portion of the study, we wanted to explore further how the different management strategies in dry farm soils are impacting soil health. And with these helped us just understand better how is it that these soils are responding, and also what are the characteristics that are allowing these systems to provide the water that the vines need throughout a growing season. For this project, we selected 15 dry farm vineyards between Napa, Sonoma, and Mendocino Counties. And for each of the selected vineyards, we had 2 fields that we selected, and that gives us a total of 30 different sites that we are working with. In order to begin understanding the soil health aspects and the water dynamics, we decided to do soil pits to collect soil samples and also to begin investigating the development of the root systems. We collected soil pits down to 5 feet 3 times during the year in 2025. We went at the beginning of the season around bud break, around the middle of the season during variation, and then we went after harvest. We collected soil samples from these pits and sent them to a laboratory to look at soil physical, chemical, and biological properties. And we were also measuring the amount of moisture in the soil throughout the season. Here are some pictures from the soil pits that we dug, and you can clearly see that we have root systems that are going quite deeply. We are not surprised by this. We were expecting that we were going to find root systems there. What I think was most surprisingly was to see that the roots are not only going deeper into the soil, but also are going across. In some instances, we were finding root systems going across the two rows. So this tells us that the vines are accessing water from a much larger volume of soil than irrigated vineyards. So this is part of how is it that these systems are able to provide water for the vines throughout the season is because the root systems are pretty much everywhere in the soil, and they are accessing all of these stored moisture in the soil during the growing season. One thing that we wanted to explore was how the different management strategies in dry farm soils are impacting soil health. So in order to assess soil health, we're looking at physical, chemical, and biological parameters. Just like when you and I go to the doctor and they take our blood pressure and urine and all sorts of other tests to just determine how our bodies are doing, we can send soil samples to a laboratory so that we can test for different things that can let us know how the soil is functioning. And a well-functioned soil is a soil that we consider healthy, that is able to provide the water and the nutrients and everything that the plants need. Some of the tests that we conducted are organic matter and carbon, and this is basically the energy source for the microbes, but it's also influencing how the soil comes together to form aggregates. And this in turn impacts how the soil is able to store water. We were looking at active carbon and soil respiration and potential mineralized nitrogen as ways to look at how the microbes are reacting. Active carbon provides the energy source for the microbes, and then soil respiration and potential mineralized nitrogen are indirect ways to assess how the biology is responding in the soil. We also looked at physical indicators like aggregate stability, and this gives us a direct indication of how the soil is able to absorb water without eroding away. So it's a measure of the physical integrity of the soil. And then we also look at cation exchange capacity, which is a way to measure the ability of the soils to retain nutrients. And together, all of these assessments gives us a holistic view of how the soil is function, and together we can determine the current state of the soil health. So in order to determine how the soils that we're looking at are doing, we wanted to have a frame of comparison. So the way that we are comparing our dry farm soils is by looking at a database that was developed by the Soil Health Hub, where we collected over 600 soil samples in irrigated vineyards. So we have a database of irrigated vineyards looking at all of these soil health indicators. And what I did was just basically compare how the dry farm soils are doing. And I'm just categorizing them as scoring below, within, or above in comparison with similar irrigated soils with similar soil texture. So what we were able to see is that the great majority of the dry farm soils are scoring at least within, if not above, comparably to the irrigated soils, with only a small number of soils scoring a little bit lower. So this is telling us that for the most part, dry farm soils are doing really well. In regards to these soils that are scoring a little bit lower, we were wondering if is there's anything in the management that is happening in dry farm soils that could be impacting the way that the soils are responding. And one of the things that we were curious about was tillage, because in general terms, excessive tillage is expected to lower some of these soil health scores, degrades the soil structure, removes organic matter, and tillage can be a widely adopted practice in dry farm soils, although not in all of them. So for the samples that we collected, we had a little bit of everything. We had some soils that were not tilled at all, and then we had some soils that were pretty heavily tilled. And looking at all of the data, we were not necessarily able to pinpoint that these lower scores are directly related to tillage, because we had some tilled soils that scored pretty good, and we had some non-tilled soils that didn't score that high. So the tillage in and itself was not something that just based on this smaller data set it's not something that we were able to tell that is impacting soil health. And the reason I think this is happening is because tillage is not just happening isolated in dry farm soils. It's been done in combination with very robust, very healthy cover crops with additions of compost. So the compost and the cover cropping are counteracting any potential negative impacts that tillage may be causing in the dry farm soils. So with that, what we can say is that potentially these could help prioritize which soils could benefit from some reduction in tillage. By no means can we say that tillage is impacting the dry farm soils. So in a sense, this allows to give some people peace of mind that even though they're tilling, because they're also using cover crops and compost, they can rest assured that their soils are doing really well. For other folks, we can say that maybe it would be important to prioritize how tillage is impacting soil health. In more general terms, this could be a second chapter of this study, which we could actually take some dry farm soils that are heavily tilled and then establish an experiment where we would reduce the tillage and then investigate further to what extent reductions in tillage would improve soil health. But for the moment being, we can really see that tillage, as long as it's being done with cover cropping and compost, is not impacting soil health negatively. The other thing that we were looking at is just the way that the soils are storing and mobilizing water. So for that, we're looking at three parameters. One is the total amount of water that is available, and we're comparing that to what we would expect based on the soil texture. So for that, we were able to see that pretty much every single soil that we analyzed as part of this study is scoring within or higher than what would be expected based on the soil texture. So that tells us that even for those soils with lower or relatively lower soil health scores, we're seeing that they are able to store water quite efficiently to a point that we can see that they're doing fairly well comparably to what we would expect based on soil texture. The other two things that we are looking at is the field capacity, which tell us the maximum amount of water that the soil can retain. And then we're looking at the opposite of that, or the permanent wilting point, which is the minimum amount of water that the soil can store before the plants experience significant water stress. And with this, what we were able to see is that for 2025, the majority of the soils that we studied actually began the season with less water than they could have retained, meaning that the soils had the opportunity to store more water if we would have had more rain. And then on the opposite end, looking at the permanent wilting point or the lower end of the water storage, we were able to see that pretty much all of the soils are able to provide all the water that the plants need throughout the season. And at the end of the season, we had some soils getting pretty close to that lower end, and another soils being able to provide water more efficiently. So all of the soils provide the water that the vines need, but some end up the season with maybe more margin of error than others. But for the most part, we saw that every single soil was able to provide what the vines needed throughout the season. And then the last piece of the puzzle is looking at how water is changing throughout the season. So in these graphs right here, I have the soil depth, and then we have the moisture during bud break in green, aeration in purple, and post-harvest in orange. And we can see how it's changing by depth, but also how it's changing throughout the season. And I think one of the most surprising things that we saw during this study was that moisture is not only declining as the season progresses, but it gets to a point where after variation, we see a re-equilibration and a redistribution of moisture to a point that in some cases we ended up with slightly more moisture after harvest, even compared to variation. So what this is telling us is that as the vines are slowing down, and then after harvest, when they're not consuming as much water, just through the physics of the soil, we see water coming potentially from lower depths and redistributing itself to the upper horizons in the soil. So what this tells us is that even though the vines are consuming water and it gets to a point during variation that they might experience some water stress because the moisture is depleting, after the season is over and after harvest, there's an addition of water that is being redistributed from lower depths. So this is telling us that at the end of the season, these dry farm systems are actually ending with a slight surplus of water. And we don't know yet to what extent this is being done by the vines themselves, meaning because we have all of these root systems quite deep into the soil, if the hydrological functioning of the roots sucking up water during the season is creating some of these movements, because we didn't have an opportunity to do the same study in irrigated vineyards. This could open up an opportunity to replicate this in irrigated vineyards to see to what extent this is happening. But for the moment being, what we can say confidently is that at the end of the season, we're actually seeing redistribution of moisture to a point that we end up with some surplus towards the end of the season, water that can potentially be utilized for the next season. And this is particularly important in years of drought, where if we don't get enough rain the following season, but there's some leftover water stored in the soil, that could actually help the vines begin the season in a much better position than if there was no water stored there. And we saw this pattern pretty much in every single vineyard that we studied to different extents. So we see these drying of the top layers of the soil at the beginning of the season as the vines are consuming water, and the heat from the sun is also taking up some water. And then later on in the season, we see that the vines are primarily relying on water at deeper layers. And then after harvest, we see that there's actually moisture being redistributed from even deeper layers in the soil up closer to the root system. So what our research is telling us, first and foremost, is that the way that dry farms are managing their soil is, for the most part, conductive of good soil health. So this is telling us that the way that the farmers are approaching the way that they manage the soil is actually benefiting soil health, to the point that these soils are very efficient at storing and mobilizing water. We're actually seeing that there is good indication that we have redistribution of moisture in the soil later in the season, to a point that we end up with some surplus water at some layers in the soil. And all of this together is telling us that dry farming, it is a great strategy to adapt to climate change, especially in seasons where there's not going to be enough water. So even for anybody that it might not be interested in transitioning completely into dry farming, incorporating some of the strategies that are being utilized in dry farming, like heavy, healthy, robust cover cropping, compost applications with or without tilling, could benefit the way that the soils are storing water. So altogether provides a fantastic opportunity to create resiliency against climate change. With that, I thank you. I leave you my contact information in case anybody is interested on continuing the conversation. Not sure if we're going to take questions right now or we're getting at the end.
We're going to do them at the end. So just a reminder that if you have questions, you can put it in the Q&A or the chat, and we'll get to them all at the end. And now we're going to pass it off to Yvonne.
Great. Thanks so much, Lauren. Let me just start sharing my screen here. All right, you see that okay? Okay, perfect. Great. Yeah, thanks again, Lauren, for organizing the webinar here. It's great to be here, and thanks to all of you for showing up. My name's Yvonne Sokolar, and I'm a researcher at UC Berkeley. Oh, sorry, am I sharing the wrong screen?
Yeah, we see the presenter version. Yeah.
Perfect. Okay.
There we go.
Great. Um, Great. So, like I said, I'm a researcher at UC Berkeley, and I'm going to be sharing some findings from our research group today. We designed this research in conjunction with growers, with this dry farm advisory group. And the goal of this research was to be as relevant as possible to dry farm management. So today I'm going to be telling you about that project. And I want to start out by acknowledging our amazing research team. So we have Delphina, who is a PhD student in the lab, Patrick McCurry, who is a staff researcher, and then Tim Bowles, who's the PI for the group. Delphina was leading most of the field work, and Patrick was working on the qualitative interview work that I'll show you in a second. And let me see, the sharing is weird. I'm just gonna stop sharing for a second and reshare and see if we can make it less funky. Okay, my apologies. Here we go. So share again. Okay, sorry about that. Back on track. So the field study is built around 8 dry farm sites across 3 counties, Napa, Sonoma, and San Luis Obispo. We paired each dry farm site with a nearby irrigated counterpart. So this was on average just, a half mile or so away. And we also match for soil type, grape variety, vineyard age, and that has let us isolate water management as the key variable of interest in the study. Um, the goal of this work is to build evidence for the trade-offs and benefits of dry farming as a climate resilience strategy. And we have a particular focus on whether restricting water affects carbon accumulation in the soil, and stress responses in the vines. And that was agreed upon with the dry farm growers who we were collaborating with to make this project. These were the topics that were most interesting. This is just a map showing where all our study sites are, and you can see how closely paired they are to each other. The blue dots are irrigated sites, and the green dots are dry farm sites, so tried to get things sort of really as closely paired as possible. On the interview side of things, the quantitative component of our study covers interviews with 21 growers that were managing 29 vineyards across Napa, Sonoma, and SLO again, and also all the way up to Mendocino and down to the Cuyama Valley. We included everyone from the field study that I was just talking about, and then also asked to be connected with other dry farmers and quality and sustainability focused irrigated growers. And we conducted semi-structured interviews. It wound up being that roughly half of the interviews were with dry farm vineyards and half were irrigated. Um, and as I mentioned, all of the growers we talked to are quality focused, and that was a really important selection criteria because it let us ask why growers with the same goal at the end of the day were making different choices about their water management strategies. So I want to start off with some field results. We went into this project thinking that dry farm vines would show higher water stress because they're receiving less water. And that actually turned out to largely not be true. So instead, one of our central findings is that dry farm vines don't show more stress than their irrigated counterparts. We see minimal difference in stem water potential. That's on the left here. And the way this graph works, if these dots are farther to the left, it means that dry farm vines are more stressed. If they're farther to the right, they mean that irrigated vines are more stressed. But when you see these lines crossing this dashed line here, it means that there wasn't actually really any meaningful difference. So we can see that with dry farm vines are maybe just starting to show higher stress levels in August, but there's no difference for the rest of the season. And then on the right-hand side, these are differences in photosynthesis. So this is basically how productive these vines are being, or one measure of that. And it also maps really tightly. I don't have stomatal conductance on here, but it's a similar pattern because photosynthesis and conductance are very linked. And so we can see that there's no difference whatsoever in photosynthesis over the course of the growing season. And that suggests to me that dry farm vines are adapting to their conditions. So they're finding water deeper in the soil profile instead of suffering too much from its absence. And at the same time, it's important to remember that irrigated vines are probably also somewhat stressed. And I'll talk more about that in a moment. But just to summarize here, what we're really seeing is that dry farm vines and irrigated vines show the same stress levels. And that's probably achieved with different rooting strategies, which we'll get to here. So that lack of a stress difference really got us thinking. And the question is then, if dry farming doesn't lead to any detectable signs of increased stress, why are some growers still irrigating? And again, that gets back to this goal of high quality grapes. These are growers in regions like Napa that have a real reputation for high quality grapes and high land values, reasons that they sort of have to be producing high quality grapes. And in order to achieve that goal, there's these 2 different strategies that farmers are using, because in order to make high quality grapes, you have to have some level of stress in the system, specifically water stress. So we found that in the interviews that dry farm and irrigated growers operate under two pretty distinct philosophies. For the most part, dry farm growers described accepting the constraints of their environment. So they don't use water inputs. Instead, stress emerges naturally from the site. Um, and of course, I also just want to note that there are limits to what a given site can support. Some of our dry farmers actually also irrigate other blocks in their vineyards, depending on things like slope or soil type or rootstocks. But by and large, where they could, dry farmers were allowing the natural constraints of water availability to guide their product quality. Irrigated growers, on the other hand, describe something that's more like a control of the system. So they add water early in the season and then withhold it deliberately to engineer stress at exactly the right moment. And as you can see, we're calling these two different philosophies constraint and control. They're both just different means of getting to the same end of reliably high quality grapes. And I also just want to focus on these pictures here for a moment. These were roots that the folks at Dominus have collected to illustrate the difference between dry farm and irrigated roots. And on the left, you can see these dry farm vines here that are going straight down deep into the soil profile. They're still very thick, even past the bottom of what I've cropped off of the picture here. Whereas irrigated roots, this is sort of an extreme example, but the plant is sending energy to rooting energy to where water is. And so for these irrigated growers, if you can keep the surface soil moist, roots are going to go there, and then you actually have more control over what's happening in the roots. You're able to stress them more easily when you cut off the water. So you're actually forcing the roots into a place where you can still access them and then manipulate them. Interestingly, so beyond water application, the two systems were actually a lot more similar than I had been expecting. We went in assuming that dry farming would look really different from irrigation, sort of across the board regarding management decisions. But we found that pruning, thinning, cover cropping, trellising, even tillage, which is pictured here, are fairly similar across groups. So what you're seeing in this image is the number of tillage passes across the x-axis here. And this is over the course of one growing season. And there's irrigated growers on the bottom here and dry farm growers on the top. And certainly it's true that the dry farm growers that are tilling the most are tilling more than the irrigated growers, but there's a lot of overlap and a lot of dry farmers that aren't tilling very much at all. So even with tillage, which dry farmers think of as pretty essential to the dry farming management systems, it's distributed pretty similarly across both of these groups. And that was true, like I mentioned, for other practices like pruning, thinning, all these other things. That tillage idea is illustrated in a little bit more depth in this figure here. What we're seeing is across the bottom, there's dry farm and irrigated growers, and they're color-coded and just arranged in ascending order of yield, which you can see in these pink dots here. And then you're also seeing the orange bars are the number of tillage passes, which maps to this axis, and the blue bars are the amount of water applied, which maps to this axis over here. So tying it all together, we see again that some dry farmers do a few more passes than irrigated growers who are the heaviest tillers. So that's these, highest bars here are going to be your dry farm growers and not your irrigated ones. And you also can see that really the only hard line between these groups is whether or not irrigation touches the soil. So all of these irrigated growers have blue bars, all of the dry farm ones don't. And even in terms of yield, which is an important management outcome, of course, there's a lot of overlap in how much irrigated and dry farm growers are achieving in terms of yields. And so with all of that management overlap, we started thinking about how dry farm and irrigated growers turn out to be different more in terms of philosophical and identity-based measures than strictly in terms of operational differences on their farms. So given that these systems have so much overlap in terms of vineyard management, the obvious question then comes up of, okay, what's actually driving the choice of whether or not to irrigate? So four things came through really consistently in the interviews. The first was, of course, site suitability matters, but it actually turns out that most Napa growers probably have what's needed to dry farm on their sites in terms of site suitability. Actually, all of Napa used to be dry farmed just a few decades ago in the 60s and early 70s. So site alone doesn't explain why growers are making these choices. Instead, one of the biggest factors that we found is inheritance. So dry farming in the sample is often something that was handed down to current vineyard managers. And then there's scale. So every large operation in the study irrigates every operation that has more than 250 acres. And that makes sense, right? Because at scale, you need to be able to control what's happening and have the uniformity that comes with that. Um, and then finally, risk. So irrigated growers tended to see dry farming as a risky endeavor. So there's this perceived risk of adopting dry farm management. Um, but the reality of it is that dry farm growers reported their systems actually hold up better in drought sometimes than many irrigated vineyards. So there is for folks that aren't dry farming, there's this perceived risk to it. And for folks who are dry farming, they have found that that risk is really not very present or even works in the other direction with dry farm growers having an easier time during droughts. Um, so this is a moment where the context that these growers are operating in is really shifting. As you probably know, the wine market right now has more supply than demand, and several people that we talked to described 2025 as the first year they've really struggled to sell fruit. And in that environment, dry farming and sustainability practices are becoming real competitive advantages, or growers are telling us that they've been real competitive advantages for them. Um, on top of that, pressure to bring groundwater basins to sustainable usage levels is also growing across the region, which might start to change the calculus for irrigated operations over time. And of course, climate change is a fundamental pressure that's driving the appeal of sustainability as well as the need to prepare for future water scarcity. And with all of that weighing on growers' minds, um, the growers that we were talking to also said that it was really important to them that we ask whether water saving benefits of dry farming were coming at a carbon cost. So going back to the quantitative data, we wanted to make sure that, or not even make sure, but just understand what was happening in terms of carbon dynamics in these vineyards, especially given that there's reported higher tillage. Miguel set this up very well in terms of potential carbon losses from tilled operations or more heavily tilled operations. But we actually found that there was no difference in carbon in dry farm versus irrigated vineyards. We didn't see any trade-off. Again, the trade-off being in terms of carbon and water savings, at least compared to the irrigated vineyards in the top meter of the soil. It's not pictured here, but also above ground carbon stocks. So the carbon that's actually held in the vines themselves weren't different between irrigated and dry farm vineyards either. So to sum that up, dry farming doesn't appear to compromise carbon storage, which really matters for anyone thinking about trying to employ dry farming as a climate strategy. Okay, so what do we take away from all of this? On the quantitative side, dry farm vines show no meaningful difference in water status or photosynthesis, and there's no carbon trade-offs to dry farming that we can detect at least. On the qualitative side, the choice between dry farming and irrigation is less about what's agronomically possible and more about what was inherited. Also, the scale of the operation and how risk is perceived, which again is different from how risk is actually experienced. And as water pressure grows and markets tighten, we think that the case for turning off irrigation is probably going to get stronger. So really interested in seeing how these dry farmers are making these systems work and exploring ways that we might shift towards more dry farming in the future. So thank you so much. I'll stop sharing my screen here and pass it over to Mike.
Thanks, Yvonne.
Wonderful. I think that is a fantastic segue into talking about the costs associated with dry farming. So as we've seen, it's it the management techniques aren't that much different. And so what we did in our section of the study at ERA Economics, along with well, myself working with Tori Laird and Duncan McEwen, is we looked in and interviewed a host of dry farmers over the same regions in Napa, Sonoma, and here on the Central Coast where I'm at Cal Poly, and to look and see what are people actually paying. And we came up and built a bunch of economic models that are user friendly that people can take and dive into things at their own particular site. Through going through all of this from the economic perspective, we asked ourselves, like Yvonne said, if a lot of these vineyards were dry farmed originally, why did they move into irrigation? And that is, it's just one of basically three reasons, again, from this economic perspective. The first is to reduce risk, right? To manage and control. The second would be to increase yields in those areas where you wanted to pump up yields, to build things out. And again, this might be one of those questions where we're thinking about the difference between quantity and quality. And then the third reason is to farm areas that weren't typically farmed because of water constraints. So what we did is we went through various grower meetings and workshops, and we developed three user-friendly enterprise budgets. So cost of production, cost of establishment, and then cost of operation over the lifespan of the vineyards. I'll show you one of them for Napa in a little bit. And then we dove in on some very specific cases for vineyards, looking at and did short case studies looking at establishment costs, transition costs, which I think is very interesting, and then how dry farm vineyards can be managed in an arid region where variation in precipitation really does have an effect on yields, and how you might think about that management differently in terms of that. So as we've seen before, there's a lot of potential benefits for dry farming. And what our goal was to try to take these in and move them in from the cost perspective or a yield perspective. And one of the clearest benefits that we're seeing is reduced application of water and the costs associated with that, with maintaining irrigation lines, with having irrigation labor that's out in the field every year. And then pests and weed pressure has been another really big cost consideration that's come up, as well as vine longevity. So if we're comparing average age of dry farm vineyards versus irrigated vineyards, like in Napa, but the average age of the irrigated vineyard in Napa is around 25 years. The dry farm vineyards are much, much older. What we then really wanted to think about was trade-offs, right? From an economic perspective, everything is about trade-offs. And if I'm going to try and reduce risk because of weather fluctuations, then I'm going to have increased costs from managing that risk. And so what are the other trade-offs that were involved? The biggest, really the two biggest ones are establishment costs and in terms of labor. So how do you establish your vines? Do you go through and you irrigate them by hand? Do you have water carts that are pulled behind? Do you lay out an irrigation system that then you're going to pull back up in 3 or 4 years afterwards? And we saw a huge variation among our dry farm vineyards and how people do it. And I think that really brought up one of those interesting aspects of dry farming, and that it's very specific and site specific. Talk a little bit about that in a second. The other thing that was interesting is cultivation and how much dry farmers typically cultivate. But as we just saw, it's not necessarily more. And if we do comparisons across older enterprise budgets, the number of passes through a vineyard, be it cultivation or for spraying herbicide or other things, are about the same depending on where you're at, or less if you're dry farming. So we dove into all of these, thought about all the different ones. I mentioned establishment, irrigation, pulling hand carts, those types of things. Vineyard spacing has also been argument about the differences between dry farm and irrigated. Typical old school vineyard spacing for dry farm is a lot bigger, maybe on a diamond pattern, 12 by 12 or 10 by 12. Whereas if I'm Irrigating, I can put some more in there, but that really depends on where you're at and how much precipitation you have. So we have dry farm vineyards in the mapping data set that are really, really tight, and some that are more the old school style. And so there really wasn't a whole lot of difference when we're comparing tons per acre in yield, like we just saw with Yvonne's data set, which is just fantastic. And so then from an operational standpoint, right, what are my cost differences year to year after establishment? No cost associated with irrigation, which is big, right? You're no cost associated with maintaining irrigation. How you fertilize, if I don't have fertigation set up, maybe some of them still did and applied that. But if I didn't, I might have to go out and do it differently. As Miguel said, though, that all of these dry farm vineyards that we went out had a host of other practices. And so a lot of them maintained a lot of their fertilization through cover crops and different aspects, like choosing these things different, marrying these things with the soil types, and then how they create the dust mulch for those that did. I think the really big thing that got into it, and as I said before, is that site really matters. The thing that I really liked about getting into and talking with everyone was understanding that dry farming isn't prescriptive, is that it's site specific. And there's a lot of practices that folks that dry farm and irrigate, they've taken some practices from the dry farm vineyards and applied those to their irrigation vineyards. So just drop back some of the irrigation or applied it differently and use some different methods. Average rainfall, groundwater access, riparian rights, soil type, slope, all of this matters, and all of those techniques that the dry farm vineyards use. And so we took all of these for our 3 different sites for our enterprise budgets, combined them together, and came up with some average numbers for production costs. And so we've got narratives that are associated with all these enterprise budgets. And I'm going to zoom in on this one in just a second here. And so we've got narratives and kind of a hypothetical vineyard in the area. So Napa's 30 acres of Cab Sauv with clay loam soil on a fairly flat area. So if I jump over really quick, I can show on my Excel budget here. So we've got our Excel files that are going to be accompanying with our narrative spreadsheets that have these overview tables. And it's all set up to be user friendly. So we can take this. So the base numbers that are in here are based on the number of folks that we work with to come up with a nice general average. So we've got an introduction sheet. And then we have our input sheet. I know this is a lot of information to see, but it's just a quick overview where we've got reference numbers right here, say for yields, by year, cultural practices by year, how you go through. And you can go in and you can say, well, I end up spending a little bit more on my cover crops, or I end up spending a little bit less on erosion control this year to that year. So you can change these numbers. And when you input your own numbers there, that all rolls over to this enterprise budget. So the enterprise budget here goes out to 40 years, and it dives into establishment costs. So you can see here, so vineyard removal, if I have it, layout, replant, all of that kind of stuff. And then it gets into cultural costs that are annual cultural costs where you can go through and see what those look like, as well as cash overhead costs. So these are very close to the enterprise budgets that are developed at UC Davis, Oregon State, Washington State University, which all are very closely aligned. And we can see how things lay out. And in fact, the most recent UC Davis enterprise budget for Napa County Cabernet Sauvignon, which was 6 or 7 years ago, developed 6 or 7 years ago, has total cash cost of production. That's about the same as what we've estimated here for 2026. So in terms of cost of operating a dry farm, it looks like it's costing about the same, again, for our representative vineyard here in 2026. Dry farming in Napa County as it did in 2020 for an irrigated vineyard. So that's great to know. And then we've also included a net present value table to think about what are some of the assumptions that we might take this and think about how lifespan would affect the profitability of these vineyards. And so you can go through here and input your own, zoom in, input your own price per ton, tons per acre, and then your lifespan, and then a discount rate for calculating net present value. And it'll calculate out what the value of an acre would be. So for a 40-year lifespan, the net present value of this particular vineyard is $354,000, which is quite a bit. And again, if we would compare that to the average lifespan, which is 25 years, that's $200,000 less per acre. We can also look through our data table here, which shows the differences between lifespan and price per ton coming off that acreage, and we can make these comparisons. So these are developed. I'm going to go back to our presentation. These are developed for our 3 regions. So Napa here, and then Sonoma, which we assumed 55 acres of Pinot Noir on sandy soil. And because it's sandy soil, the need for cultivation is much, much less. And so you have lower levels of cultivation for that and higher returns, at least at that level, depending on what your income is. So gentle rolling slopes. And then down here, the Paso Robles, where we have a smaller block, but really high alkaline soil, fairly steep on the slopes on the west side over here. And again, here's a snapshot of the difference between vineyard lifespan and returns. And so you can go through in here, you can input all your numbers again, and you can come up with some of these estimates and look at what these differences are. All in all, over all of our discussions with everyone, costs are generally the same. They're spread a little bit differently, but overall they're generally the same or just a little bit less. And so this is our next one, our one of our case studies. And I'm going to show you 2 here just briefly, and we're still developing our 3rd one, which will be interesting. Dive into the arid regions. But for our transition case, so this is looking at transitioning an irrigated vineyard into a dry farm vineyard. Their yields were 3.5 tons per acre. It took them 4 years to get back to full yields, and they're back to 3.5 tons growing dry farm. But this is up in Sonoma County again. Revenues, they're getting the same revenue per acre as they were before. So they've maintained quality. They've maintained those contracts to get that. But their costs have decreased $2,000 an acre because they're no longer having to pay for management and irrigation and labor every year. So even though they saw drops in yields in those first 3 years, they came back into the positive side on the other because of reduced costs of irrigation. Another case study that we did is looking at new development. So how much does it cost to develop an acre for a dry farm vineyard? So this is fresh development. Again, this doesn't incorporate any potential regulatory costs for those types of things, but just straight operational costs for development. And it's running around $52,000 an acre. So really no difference if I'm going to develop dry farm versus irrigated vineyards. It's all just kind of how it plays out over the first few years. It's spread a little bit differently in terms of establishment for those fines, and then on the line. With that, I'm going to say thank you and leave us hopefully for some time that we can answer some questions. Appreciate it.
Thanks, Mike. So Yvonne, there's a question for you. She wrote, am I understanding correctly that even if dry farming requires extensive tillage, there was no observed carbon differences between irrigated and dry farm vineyards?
Awesome. Yeah. Thanks for the question, Catherine. So I think you are mostly understanding that perfectly correctly. The one thing that I would add is that I think part of what explains this is that there isn't as big of a difference in tillage as we were expecting to see. So there's lots of dry farm growers who till as much or less than irrigated growers. And so with that overlap, you wouldn't necessarily, like, you wouldn't expect tillage to be causing such a big difference in carbon. And then without tillage in the equation, or with tillage kind of a wash in the equation, we weren't finding a big difference between carbon in irrigated and dry farm sites.
And then from Tommy, any insight on dry farming and potential effects on powdery mildew? I dry farm in Sonoma with a friend, and we noticed at the dry farm site, we need to do a fraction of the powdery mildew sprays, and wondering if it's somehow connected to dry farming, less humidity and canopy, maybe less canopy vigor, but results show similar above ground vigor. So for me, I haven't seen too much of a difference in my dry farm vineyards, but I don't know, Yvonne, if maybe when you were talking with some of the growers, if that ever came up.
Didn't come up in our interviews. I don't know if anyone else here has more experience with that.
No, I mean, Tommy, I'll look into that. And then also, if you want to send me a message with your email address, I'd love to see if we could get your dry farm vineyard on our map. Um, Then from Frank, why would tillage be required with dry farming? Please define tillage. Okay. So when we dry farm a vineyard, we're trying to conserve the moisture in the soil. And by doing that, we almost create, it's like a dust mulch on top. So we break down the soil. So we mow, we disc, we cultivate, sometimes rototill, so that we're breaking the soil down on the top layer. So it's like a crust and it seals in the moisture. And so, in places like Napa, that's a big tool for dry farmers. Down in Paso, for sure. We've kind of seen that in some places like Sonoma and Mendocino, where they might receive more rain. They don't have to um, till as much or at all. So for us, it is definitely being able to create like the soil to be a sponge and then to be able to conserve and store the moisture in the soil during the hot months. Let's see. I'm from Caitlin. I'm trying to understand more about the intersection of dry farming and biochar. So would love to hear if there are any growers actively using biochar. Miguel, do you know about this? Have you heard anybody using biochar?
I'm currently working with some farmers using biochar, but not in dry farm systems. And that would be a very interesting thing to explore. Currently, we have an ongoing research project. We're in our fourth year now where we apply biochar and compost to an irrigated vineyard. And after 4 years, we yet haven't seen any differences in the water storage. We've seen some differences in some of the biological components, but it's still, even after 4 years, it's pretty early to tell. So I have not yet worked with anybody dry farming that is using biochar. In general, we would expect a potential increase in the water storage just by the action of having the biochar. But the reality of it is that it's something very new in the research area. So there's still a lot more information that needs to be developed before we can say any of those benefits are conclusive.
Thank you. This is for Yvonne from Jennifer. I think you mentioned irrigation being associated with larger operations. Was there a typical acreage for the sampled dry farms, i.e., 100 acres or less? Wondering if there's any instances of large dry farmed operations.
Yeah, great question. So from the folks we talked to, the largest operation we found was 250 acres, and the average was 93 acres, down to 5 acres at minimum. And but there was only three operations that had more than 100 acres, three dry farm operations that had more than 100 acres, which by comparison, the irrigated vineyards, more than half of them manage more than 1,000 acres. So it's a really pretty substantial difference in vineyard size or operation size.
Okay, so this is for all of you. What would you like to research next with dry farming? So, Miguel, we can start with you. If there's something that you see that would be to continue this project.
Right now, for me, the main thing I would like to really get more insights into is the impact of tillage. If we were to actually isolate the practice of tilling, meaning take a dry farm vineyard that has been tilled 5, 6 times during the year for a long time, and then break that apart and reduce the tillage, then track how that it's impacting soil health, to me would give us a lot more information versus trying to compare between different dry farm systems that are either tilling or not tilling. So far, it's the information is telling us that the addition of compost and cover cropping might be counteracting some of the potential negatives of tillage, but the reality of it is that the experiment wasn't designed necessarily to tell us specifically the impact of tillage. So to me, I would like to explore that further.
Thanks. Mike, do you have or Yvonne, do you have we'll start with Yvonne.
Sounds good.
Sorry.
No, you're good. So I think for me, two answers off the top of my head. One is that I would love to sort of do a bit of a retrospective and look at the history of how it came to be that all of these historically dry farm vineyards switched over to irrigation in the 70s. I think especially thinking forward to how we might encourage a switch back in the other direction, it's important to understand how we got here in the first place. And then from a much more boots on the ground in the field kind of perspective, we tried really hard to figure out what depth of, like how far down into the soil profile different the dry farm versus irrigated roots were going. And it was really difficult to get clean data on that. But I would love to sort of go at it again and see if we can find ways to understand the root distribution in dry farm versus irrigated vines and see if we can really confirm this hunch that we have about how it's just sort of two totally different rooting paradigms in these different systems.
From my perspective, just really quick from the economics, I would want to think about what risk management practices, how those are different between irrigated and dry farm, and then how the implications and implementation of Sigma and groundwater management is going to play out with the difference between dry farm and irrigated, especially if we're talking about shallow water tables versus deep water tables and shallow and deep wells and how infiltration works with the two different systems.
Well, thank you guys. Thank you so much for presenting on all of your research. And I put my email in the chat. So if anybody has any other questions, please reach out to me. And I also put the links to the websites to take a look. We'll keep posting our research results there, the dry farming guide. You'll be able to see the map. You can see some of the videos that are already live. So please take a look and let me know if you have any questions. And thank you all for joining us today.
Thank you all.